Welcome back, Chemistry 30s. Hopefully you had an opportunity to work on the second example. So of course we know copper is going to be undergoing a change, nitrogen is going to be undergoing a change. So that'll help us figure out our two half reactions. And let's see, NO3 negative going to NO2. Okay, so let's work with this side first. So one copper, so we're good there. We don't have any extra O's, we don't have any extra H's, so all we have to do, we can jump right down to the balancing charges. So here, of course, we have one copper atom, or solid, it's no charge, so it's just 0. And over here we have one that's 2 positive, so that is 2 plus. So I add electrons to make the charges balance. So again, I add electrons to the more positive side. So I need to bring this 2 down to 0, and I do that by adding 2 electrons. So the overall equation is going to be this. Copper turning into copper 2 and releasing 2 electrons. So that's the oxidation part of it, as you can see. Over here, one N and one N, so we have the N's balanced, but we're short on oxygens on the right, so I make up for that by adding water. So 3 oxygens, 2 plus 1, 3 oxygens, but of course in the process I've added 2 hydrogens, so I have to add 2 hydrogens there. So now everything is balanced, so I just have to look at charges here. So I have a 1 positive here, and I have 2 of them. And I have a 1 negative charge here, and I only have 1 of those ions. So 2 positives and 1 negative leaves me with a net result of 1 positive. Over here, I have no charge, and I have 1 NO2 molecule, so it's just simply that. No charge here, I have 1, so in total here I have a charge of 0. So of course the more positive side is over here, and to bring this down to a 0 I add 1 electron, so this overall equation here is going to be 2 H pluses plus NO3 negative plus 1 electron yields NO2 plus H2O. So when you're all done this process, you should have one side have electrons and the opposite side having electrons in the other equation, and that's in fact what we have here. So over here, we ended up releasing 2 electrons. Here we ended up gaining 1 electron. So the lowest common multiple here between 2 and 1 is 2. So I'm going to have to multiply this whole equation by 2. So 2 times 2, 4. 1 times 2, 2. 1 times 2, 2. 1 times 2, 2, and then 2 over here as well. Okay, so I should have everything that I need. Now I just need to combine the 2 equations together. So this one over here, Cu yields Cu2 plus 2 electrons. Again, I'll write it so the arrow's underneath. Then 4H pluses, 2 NO3 negatives plus 2 electrons gives me 2 NO2 plus 2 H2Os. And then I can get rid of like items on both sides, so I get rid of that. So that will result in this. So write down all the remaining species on each side. And I should see that everything works. 4 H's, 4 H's, 1 copper, 2 N's, 2 N's, 6 O's, 4 plus 2 is 6. Then of course I could look at charges too, right? Here I have 4 times 1 positives, 4 positives. Here I have a 0. Here I have 2 times negative 1. So over here I'll have 4 minus 2, 2 positives. And over here I have 2 positive, 0, 0. Look at that. It all works out. All right, so that's how you do that. So that's how you do it when the redox reaction is in an acid. Now we'll look at what happens if it's in a base solution. So if it's in a base solution, there's only a slight tweak that we have to do. So if a redox reaction occurs in a base solution, the equation must be balanced using OH rather than H2O, or sorry, OH and H2O rather than H plus and H2O. One approach, which I think is the easiest one, is to first balance the half reactions as if they were in an acidic solution. Then, because what gives it an acidic solution is those extra H pluses. But if we can count the number of H plus in each reaction and add the same number of OHs to each side of the half reaction, we can balance it. So this way the reaction is mass balanced because you're adding the same thing to both sides. In essence, what you are doing is you're neutralizing the H pluses with the OHs. Because H and OH makes, what are those? Water on the side containing H plus. And then the other side ends up with the OH minus, which gives it the base characteristic. Gives the base characteristic. So that's kind of the trick that we use for that. So treat it as if it's an acid, and then neutralize it to make it a basic solution. So we'll look at that here. So obviously, here we can deduce that it's the C that's changing. It could be the N, but hey, so we'll combine those to one equation and combine those to another equation. So hopefully I left enough room here. Maybe just write a little bit smaller than you usually would, just to ensure that we have enough room. So Cn negative going to CnO negative, and MnO4 going to MnO2. Okay, so we'll look at that. We'll just do exactly what we did before. So C's are balanced, N's are balanced, O's aren't. So I need to have an extra O on this side. So I do that by adding water. So the O's are balanced, but look at that. I added H's there. I added two H's, so I have to add two H's here. All right? Now, that's going to make it an acidic solution. So if this is an acidic solution, easy, just continue on, count the charges, balance it out by adding electrons. But it's not in an acidic solution. It's in a base. So I didn't write it here, but assume basic solution. So over here, wherever I have the H pluses, I add OH to each side. So over here, I'm just going to rewrite this. H2O plus Cn negative. So I need to neutralize these H's by adding an equal amount of OH's. And of course, what I do to one side, I have to do to the other. Okay? So of course, this, two H's plus two OH's combine to give water. So that's, and then I have OH's on the left-hand side, as you can see. All right, so I have that. Now, what happens here is I have water on both sides, right? So I can cancel. I have one water here, two waters here. So one cancels with one, leaving me with one, because I had two over there, right? So two OH's plus a Cn negative yields this and this. Okay, and notice it's all of a sudden become a basic half reaction because of that OH over there. Now I can balance for charge. So here I have one negatives and I have an effect of two of them. Here I have a one negative and I have one of those CNs. So two negatives and a one negative gives me a total of three negatives. Over here I have a one negative and I only have one of those. Here I have no charge, so one negative. So the more positive side obviously is over here. So I can balance the charges by adding two electrons over here. One negative and two negatives gives me three negatives, which will balance with what I have on the left. So the overall reaction here is going to be that. So it's basically the same as an acidic solution with the exception of this neutralization part right here. Okay, let's do the same thing over here. 1 Mn, 1 Mn, we're good. 4 O's, 2 O's. So obviously I'm going to have to add some water to the right to bring up the number of O2s, or the number of O's. So 4 O's, 4 O's. 4 H's, 4 H's. Okay, so now if that was an acidic solution, that'd be good. I could continue on, balance charges, done. But it is a base solution, so I need to neutralize those H pluses by adding an equal amount of OH negatives. And I have to do the same thing on this side. Just move the camera over there. So I added 4 OHs, add 4 OHs. Okay, so of course here I'm going to get 4 H2Os. 4 H's and 4 OHs give us water. Okay, and we end up with that. So we should be good there. Now, can we get rid of some water? 4 waters, 2 waters. So 2 cancels with 2, leaving me with 2. So always do that. If you can cancel out water. I don't think, I said that up on top here, but you can balance that out. Okay, let's look at charges now. Water is neutral, so if I have 2 of them, doesn't matter, it's 0. This is neutral, I have 1 of them, so hey, overall charge is 0. Over here, that's neutral, I have 1 of them. And over here, I have 4 negative 1s, so that's going to give me 4 negatives. So the more positive side is over here. If I add 4 electrons, I'm going to get what I need here. So 2H2O plus MnO4 plus 4 electrons. So this side's getting reduced, obviously, because I had to add electrons. So again, you should have electrons being released on one side and electrons being added to the other. The lowest common multiple of 2 and 4, of course, is 4. So I need to change this to a 4 by multiplying everything by 2. So if I multiply everything by 2, I'm going to have 4 OHs, 2 CNs, and I can see that I made a slight error here. So if you notice, I forgot this. So actually there is an extra charge there. What we'll do is we'll stop the video here. I'll come back and I'll fix this up for us.